Now this is a question about photoelectric effect. It says a photon of wavelength 4 × 10⁻⁷ meter strikes on a metal surface. Now let me note down the data. It says lambda is how much? 4 × 10⁻⁷ meter. Work function of the metal being 2.13 electron volts. Okay, work function is 2.13 electron volts. Calculate the energy of photon in electron volts, and there are many things to calculate, it seems. First of all, energy of photoelectron, first of all we have to calculate simply energy of photon in electron volts. Now energy of photon is hc by lambda. Wow, yes. Now, do you realize that if I substitute standard SI units, I would get some number, of course. But also, do you realize that 1 electron volt is 1.6 × 10⁻⁹ joules? Okay. Well, if I dare use this conversion, can I directly substitute for h, c, this constant also, and get some number which is an easier number to handle? What do I mean? I'll just show you. First, let me do it by routine method, and then I'll tell you shortcut. 6.626 × 10⁻34 joule second, 3 × 10⁸ meters per second. We know that by lambda. The lambda is say 4,000 angstrom units, in this case. 4 × 10⁻⁷ meter, which is 4,000 angstrom units. Let me say it is 1,000 angstrom units. What? Let me just say it. Just believe it. Believe me. It's some number in angstrom units. Let's say it is 1 angstrom unit. Just for the sake of simplicity. I'm not saying in our question lambda is 1. I'm saying let us assume that we are considering a case if lambda is equal to 1 angstrom unit. And if you're not happy, just keep it as lambda angstrom unit, whatever. I get. So I'll get some number as energy of photon. How much is this going to be? Well, what I'm supposed to substitute not in terms of angstrom units here, but in terms of meters. So 1 angstrom unit would mean 10⁻⁻10 meters. Meters simply get cancelled here. That's fine. This is what I get. How much is this? 6.626 into 3 into 10⁻⁻16 joules. Right? Right. Now, this is energy of 1 photon. Can I calculate this in terms of electron volts? Yes. This would correspond to 6.626 into 3 into 10⁻⁻16 upon 1.6 into 10⁻⁻19 electron volts. How much is this? How much is this? Just can we calculate that? Yes, we can easily do that and we can get the number. And this is 12424. I mean, just these 3 numbers together into this is 10⁻³ into 10⁻⁴. Oh my God, how much is this? ये हो जाएगा 1 2 का 4 और फिर से 2 4 12424 12424 इलेक्ट्रॉन वोल्ट्स. ठीक. अगर ये सारी गंदगी अपन सॉल्व कर लें तो अब लैम्डा अगर 1 की बजाय 4000 आ जाए तो क्या होगा? तो हमने एक एक्सप्रेशन निकाली एक तरह से. कौन सा? एनर्जी ऑफ फोटॉन. आई जस्ट राइट इट फॉर यू. एनर्जी ऑफ फोटॉन is 1 2 का 424 अपॉन लैम्डा इन एंगस्ट्रॉम यूनिट्स. इतने इलेक्ट्रॉन वोल्ट्स. ऐसे. तो जैसे हमारे केस में लैम्डा कितनी आ रही है? हमारे केस में लैम्डा आ रही है 4000. तो हम कहेंगे एनर्जी ऑफ फोटॉन विल बी 1 2 का 424 अपॉन 4000. इतने इलेक्ट्रॉन वोल्ट्स हैं. और डिवाइड करना 4000 से इज वेरी सिंपल. 3 इधर गए. 1 2 3. ओके. 4 3 12, 4 1 4, 4 इतने इलेक्ट्रॉन वोल्ट्स. दैट्स इट. दैट्स इट. अच्छा, तो ये क्या आपने तो सब बोला, हम कंफ्यूज हो गए. आप तो आंसर देखो पहले तो, मैच कराओ बढ़िया मस्त. 3.10 इलेक्ट्रॉन वोल्ट्स, यस, परफेक्ट। कैलकुलेशन क्या करी थी एक बार फिर बताता हूं मैं आपको। कौन सा? एनर्जी ऑफ फोटॉन इज 1 2 का 4 2 4 अपॉन लैम्डा इन एंगस्ट्रॉम यूनिट्स। अगर आप ये फॉर्मूला याद रख लें तो बार बार H और C मल्टीप्लाई करना, जूल्स का इलेक्ट्रॉन वोल्ट में कन्वर्जन, वो सब हमने ऑलरेडी कैलकुलेट करके यहां कर लिया है। उस मेहनत से आप बच जाएंगे, ऐसे आ जाएगा। बहुत इजी है, बहुत अच्छा है, ठीक। इससे हमने निकाला 3.1 लगभग इलेक्ट्रॉन वोल्ट्स। कौन सा था? एनर्जी ऑफ फोटॉन, ठीक है सर। तो ये तो फोटॉन की एनर्जी है जो मेटल पर आ रहा है। ये है मेटल, हाँ, इस पे फोटॉन आया, मस्त, ठीक, 3.1 इलेक्ट्रॉन वोल्ट का, और फोटो इलेक्ट्रॉन निकले। तो एनर्जी ऑफ फोटो इलेक्ट्रॉन कितनी होगी? काइनेटिक एनर्जी ऑफ एमिशन, काइनेटिक एनर्जी ऑफ एमिशन इज इंसिडेंट एनर्जी, एनर्जी ऑफ फोटॉन माइनस वर्क फंक्शन, 3.1 माइनस 2.13 विच इज कितना? वेल 3.1 में से 2.1 तो 0.97। सॉरी, यहां आएगा डेसिमल, 0.97 इलेक्ट्रॉन वोल्ट। ये है काइनेटिक एनर्जी ऑफ फोटो इलेक्ट्रॉन्स, 0.97 इलेक्ट्रॉन वोल्ट्स। कुछ और हसरत बाकी है? जी हाँ, वेलोसिटी ऑफ फोटो इलेक्ट्रॉन। हो ये कैसे निकालेंगे? बड़ा आसान है। काइनेटिक एनर्जी इज हाफ mv²। अच्छा, तो वेलोसिटी इज 2 टाइम्स काइनेटिक एनर्जी अपॉन मास की गंदी वाली रूट। अच्छा, सो व्हाट अबाउट द वेलोसिटी? वेलोसिटी इज √2ek/m। यस, how much is this going to be? 2 times kinetic energy of photoelectrons. Now we know that we had 0.97 electron volt into, now 1 electron volt is 1.6 into 10 raised to minus 19 joules. Well, fancifully yes, by mass. Now mass of electron is 9.1 into 10 raised to minus 31 kg. Okay, yes. How much does this fanciful value give you? Actually, if you understand 2m and this conversion factor, they are all very common. They will always repeat themselves. So I'll just calculate, tell you, and let us learn that as a formula because we will need that very often. Let's do that. So as you calculated, it comes out to be 5.916 root of kinetic energy in electron volts. So many meters per second. Oh wow, of course, into 10 raised to 5. 5.916 or 5.92 whatever into 10 raised to 5 root of kinetic energy meters per second. If you want, you can simply take this as a formula also. This is velocity of photoelectron. The velocity of photoelectron will be, in our case, this is 0.97 electron volts. That is the kinetic energy. We take a root of that, multiply, we would get 5.83 into 10 raised to 5 meters per second. This is what we will get, right? These are the official answers. We are very close to that. That's perfectly all right.